So now chemistry is an experimental science, and so a lot of kinetics are involved with measuring the rates of reactions. So let's talk about how one might measure the rate of a reaction. So here's a particular reaction. We have NO2 plus carbon monoxide going to NO plus carbon dioxide. And one could measure the rate of decrease of the reactants or the amount of increase of the products. So let's just look at one of the products. So one might be plotting a change in the concentration of one of the products versus time. And you may find that it goes up and then maybe starts to level off a little bit over time. And now how are you going to measure a rate out of this, the rate at which this reaction is going? Well, one could measure an average rate, which would be some change in concentration over some change in the amount of time. And you could express that as the change in concentration over the change in time. So you could pick a particular interval, say, we want to measure the average rate from time as 50 seconds to time equals 150 seconds. And we'll look at how much the concentration has changed over that time interval. So we can do a little calculation of the average rate and get a number, 1.28 times 10 to the minus 4 molar per second, and that's an average rate. But if we had picked a different interval, we would have gotten a different number. So the average rate depends on the time interval. So that's not always ideal. You don't always want to know an average rate, which might be different depending on which particular unit you pick. So often when you're talking about rates, you talk about instantaneous rates. So the rate at a particular instant of time. And so let's look at instantaneous rate. So we have the same reaction, same plot, but now we're going to be considering, instead of the average rate, the rate that is the rate at a limit when your time interval is going to 0. At a very small time interval, so the rate at a particular instant. And so this can be expressed as d times the concentration of a product NO over dt. So as delta t approaches 0, the rate becomes the slope of the line tangent to the point, that particular time point that you're interested in. So let's find an instantaneous rate at 150 seconds. What is the rate of this reaction at 150 seconds? So we can look for 150 seconds. We can have a point on that curve at 150 seconds. And so as our time interval approaches 0, the rate will approach the slope of this line. So we can draw a slope that's tangent to the curve at the time t, it's time 150 seconds, and then we can calculate the slope of that line. And so we can do that math, calculating the slope, and here we find that at an instantaneous rate at time equals 150 seconds, change in, this is the slope of the line, this change in concentration over change in time, and that gives you 7.7 times 10 to the minus 5 molar per second. So that's an instantaneous rate at a particular time. What do you think the instantaneous rate is called at time equals 0? Any guess? Initial rate.